welcome to the first video in our course Competitive Programming. So in this course we are going to solve some good problems which are basically a part of competitive programming. So it will make you a better programmer and it will also help you in a lot of coding interviews. So what I will just do is I will just pick up some selected problems from various platforms like LeetCode, Hacker, CodeChef, etc., and I will just show you how to actually solve them and how what is the strategy that you can actually use to solve those problems. Alright, so in this video I'm going to choose the platform LeetCode, and this is really a very good platform. So leetcode.com is basically a platform where you can get a lot of problems and you can solve them. So the first thing I'm going to do here is I'm going to go on this problems section. So you can see this section, the problems section. I will first go on this section. Alright, so now the page is loaded. So you can see that in this problem section, when you will scroll down, you'll be able to see some problems here with some titles and some solutions also, and with the difficulty level. So basically easy, medium, hard. So in this tutorial we are going to pick up the problem number 2, which is the add two numbers, and it has a difficulty medium. So it's obvious that the task will not be to just add the two numbers. The task will be something of the medium difficulty. So once you will be able to solve the medium and hard difficulty levels, then you will be able to crack some coding interviews and you will become confident in competitive programming. So I will pick up this problem. We will just click on it. So this is going to take some time to load the whole coding playground. So it will open up the whole problem and you will be able to code inside this website only. So the name of the problem is the add two numbers, and let me just give you an overview of this problem. So you can see that now it has opened the whole you can say this is the coding playground where you can actually play with the codes. Alright, so let me familiarize you with this environment. First of all, the solution, you can see this is the description of the whole problem. This one is the description. It also gives you an example of the input and what this problem expects, which is the output, and it will give some more information also. And in this part you can see you can choose a programming language of your choice, and basically in this I'm going to solve this problem using C, because I will be using different programming languages for some specific type of problems. Sometimes I'll be using C++ or sometimes Java or maybe Python. So in this one we are going to use C. Alright, so the video might go long, so I will just tell you that you will have to be with me till the end and we will be able to solve this problem and you will learn a lot of things. So if you're new to the channel, I will suggest you to subscribe because we are going to come with some more tutorials, and please drop a like in this video because it really helps me, it supports me in making some great content for you guys. Alright, so without wasting any time, let's get started. Alright, so this is the problem. They add two numbers. You can see that it says that you are given two non-empty linked lists representing two non-negative integers. Alright, so whenever a problem is given to you, it's better that you read it and you will have to just map it on your notebook what the problem actually means. And so this means that you will be given two non-empty linked lists representing two non-negative integers. So you can see a program here. It says that the definition for the singly linked list is this structure list node, which has some value and a pointer next. So it's clear that the prerequisite of this tutorial is that you should have a good understanding of singly linked list. And in case you don't have that much knowledge, what you can just do is you can go on the website thinkxacademy.com, and this is a website that I have created so that you'll be able to see all the videos in just single place. Alright, so what you will have to do here is you will have to go on data structures. This is the data structure section, and here you can see I have created the linked list implementation in C++. So you will have to do this tutorial. So it will open up the video that I've created for you guys, and you can just watch it so that you will have a better understanding of what we're going to do. So we're going to make use of this whole concept in here in this program. Alright, so now you can see it has a return type as list node pointer struct. That means that this function is going to return a linked list, and it takes two arguments, which is one is the reference to the linked list 1 and another one is the reference of linked list 2. So now the next thing is that the digits are stored in the reverse order, and each of their nodes contains a single digit. Alright, so each node will contain only a single digit, and the digits are basically stored in the reverse order. What you will have to do is you will have to add the two numbers and return it as a linked list. So that's why the return type is of the reference to the linked list. Alright, so let's see the example here. So in this example, this is the linked list 1 and this is the linked list 2. So the digits are stored in reverse order. That means you will first have to add 2 and 5. So you will get 7. You can see here in the output you will have to just return a linked list which will contain 7 as the first node. So when you will add 4 plus 6, it will give you 10. So you will add 0 here, and you will also have to maintain a carry variable so that in the next iteration you can just add 4 plus 3 7 plus 1 8. In this manner you will get the output. Alright, so this is the given problem, and the main strategy of solving this problem is to first open the you will have to open your notebooks or whiteboard and just map that problem. So let's open the whiteboard and see what we can do in this problem and what will be the strategy to solve this problem. Alright, so now let me just try to explain you the problem. So first of all, you're given a linked list. So that is the linked list 1, and let's suppose the number in the linked list are 2, 4 and 3, and there is another linked list which is the linked list 2, and let's suppose the nodes have the value 1, 2 and 3. So this is the next pointer, and this will be pointing to null, and similarly this is the next pointer and null. So we are given these two linked lists. Let's suppose we are given these two linked lists. So I want to return a linked list. So what I will do is I will first have to create. So the step 1 is to create a linked list. Create a linked list which will basically store the sum of the corresponding nodes. Alright, so we will create a linked list L3, and what we are going to do is we're going to just take out the value of the linked list 1, the first node. We're going to create a while loop, and the step 2 is to use a while loop. Use a while loop to traverse in the linked list. I will write double L here. So we will use a while loop to traverse along the linked list, and as we travel, what we are going to do is we are going to just do the addition of these two values, and we're going to store it in the third linked list. So 4 plus 2 will give me 7 and 3 plus 3 will give me 6. So this will be the resultant linked list. So the first important strategy in these types of question is that you should first consider or create the most basic solution. You will not have to just grab the whole problem. So you can see that in this problem I've used the simple 2 steps, and what we're going to do is we're just going to store the sum. We are not handling the carry at this point, and we are not even handling some other test cases like what will happen if the linked list 1 will have only 3 values and the linked list 2 will have 2 values. What will we do in that case? So the first thing is, whenever you are given a problem, you will have to create the basic problem. You will have to create the basic solution of that. So let's now do this in the in our LeetCode. So here I'm given two linked lists, linked list 1 and linked list 2. The first task is that I will create another linked list with the name list node L3. And we know that whenever we create a linked list, we will have to allocate the structure. So, and we have discussed this in the linked list tutorial, and it is available on my channel. You can just go on the playlist and you will be able to find it. Alright, so we know that we will have to use the memory allocation function or the malloc function, and we will have to give the size of the structure like this. Alright, so this is the basic thing. You will first have to create another linked list, and we know whenever we create a linked list, we will have to just assign the value of the first node as 0. So let me just focus on the code itself so that it will become more clear to you. Alright, so you can see that I have assigned the value of the linked list L3. You can see here that this is the value inside the node, so I've assigned it as 0. So initially the value will be 0, and now I have assigned a next pointer as null. Alright, so now what we're going to do is we're going to create a value which will be unsigned, because we're going to assign sum as 0. Alright, so we will keep updating the sum as L1 value and L2 value, and we will add them and store it in a variable sum. It is unsigned because the sum can never be negative. Alright, so next step is to traverse along the two linked list, the given two linked list. So we will traverse until and unless the value of L1 is equal to null or L2 is not equal to null. So this is the first thing we are going to do. Alright, so one more important thing that we need to understand at this point is that whenever I will just, let's suppose initially we are pointing to this pointer and this one. So when we will calculate the sum, the pointer of the linked list 3 or the reference to the linked list 3 will be pointing to the first one, and when we will traverse, we will use the next pointer to go to the next value. So the pointers will change, and in the linked list 3 the pointer will actually move to the last one. So since we are actually changing the value of the pointer, the pointer is now pointing to the next values, and it goes on. What we will do is we will store the initial reference to some variable which we will call as result, and we're doing this because the pointer is updating itself, and since we have to just return the linked list 3, we will have to make sure that the pointer is pointing to the first node. Alright, so now what we will do is here I will create struct list node, and I will call this as result, and it will be pointing to the head node of the linked list 3. So I can actually comment down here that it points to head of L3. Alright, so now let's do the traversal while L1 not equal to null, or the value of or L2 reference is not equal to null. So in this scenario we will have two cases. The first is when the value of L2 is pointing to null, which means that we have reached the end of the linked list, or if let's suppose, let me just minimize that. Alright, so let's suppose you're given a linked list 1 which is 2 and 3 and then let's say 1, and you have a linked list 2 which has 3 and 1 only. So in that scenario we will see that if the value of the L2 will be equal to null, in this case we will have to perform the addition operation. So there has to be some node here. So what we will do is we will create an artificial node and we will assign it as a value 0. So the value will be 0. So now when we will add, now we will be able to add this, right? So if the value of L1, and you can see that this happens only when the value of linked list is not equal to null. So we have not reached the end of the linked list, but still we are experiencing a null node. So what I'm just going to do here is I will just allocate the node, and we know how to allocate the node. We are again going to make use of the malloc function, and now I will assign size of struct list node like this. Alright, so now what I'm going to do here is, after assigning the node, I will have to assign the value. The value will be 0, and the pointer will now be pointing, the next pointer will now be pointing to null value. Alright, and similarly we will have to do with the first case or the first linked list. So if we are experiencing some problem with linked list 1, which means there is one or maybe more lesser nodes than the linked list 2, so we are going to perform the same operation. We will allocate the node with the value 0, and I will just use the size of function struct list node. Alright, so now we are done. We have now, we will just assign the value is equals to 0 and L1 next equals to null. So this might be you might feel like this is tough, but it's not actually that much tough. You will first have to go through the linked list tutorial and you will be able to understand very quickly what these are, what are the meanings of all of them. Alright, so now we have managed to traverse. So here, let me just minimize it again, and here inside the while loop, what I will just do, I will assign the value of sum as L1, the value of the L1 plus the value at L2. Alright, so you can see here in this line we are assigning the value of sum as the value of the linked list 1 and the linked list 2, and we are going to just add it. So when we are doing this, we are actually initially the pointer of the L1 is pointing to the head position. So this line basically means that initially the whatever be the value of the head node of linked list 1 and linked list 2, whatever there will be value, they both will get add up and the value will get stored in the sum variable. The next thing is so now we have calculated the sum. Now what I'm just going to do here is I will create another temporary variable to store this value, so that if the value of the sum is changing, I'll be able to notice what the previous value of sum is, and it will be useful in the case of carry. Alright, so when I have got this value, what I am just going to do is I'm now going to show you how to actually manage carry. Alright, so I'm going to write a case here. If the value of sum divided by 10 is greater than or equal to 1. So please take a look at this case. This is the if case, which says that if the value of the sum, if you divide it by 10, so let's suppose the value of sum is 11, then if we will divide it by 10, the value will be more than 1. So we know that whenever the value of sum is more than 10, then we will have to manage the carry thing, right? So we will have to make sure that there is some carry variable, and we will have to change it accordingly. So now we are going to manage the carry variable. Initially the carry is 0, and we will change this value accordingly. Alright, so here you can see that if the value of sum is, and you divide it by 10, it's this. So what I will just do is I will just take a look at this line, and you will be able to understand what I am doing in this line. So sum becomes sum modulus 10. Alright, so let me explain what I have done at this point. So let's suppose you have linked list 1, and the value of linked list 1 is 9, 3, 2, and the value of linked list 2 is 3, 1, and 2. So in this case, you can see when we are running the while loop, the initial values are 9 and 3. So when I will add these two values, I will get 12. And we know that this is actually the sum variable. So if you will divide this value by 10, you get 2, which is greater than or equal to 1. So this condition in the if condition basically means that we are checking if there is any carry. So what I'm just going to do is, we know that whenever there is a carry, what we do is we just take the last digit, and you can see that the value is sum. So what I will just do is in the linked list 3, I will just display 2. I will display 2 here because 9 plus 3 gives me 12. So 2 will get here, and 1 will become the carry. So 1 will come here. So now I will have to add this carry variable to the sum of these two. So 3 plus 1 gives me 5. And similarly 2 plus 2 gives me 4. So what I've done here is, since we actually just need the last digit, I've written this line sum is equals to sum modulus 10. So whenever you will divide any number by 10, this is actually the remainder, so it will give me the remainder. So 12 modulus 10 will give me the remainder, which is 2. So now the value of sum is equals to 2. So now you can see the approach that I'm using to manage the carry. So this is going to be our step number 3. This will be our step number 3. And we are managing the carry variable at this point. So before managing the carry variable, we will first have to just make sure that the value of sum will be the remainder after 10, after you divide it by 10, because we don't want to store 12 in linked list 3. We don't want to store just the whole value. We will have to store the last digit only. So we are using this if else condition. So let's go on the problem again. And so now you can see here I have written, and I will write this line that sum is now single digit. Alright, so when we have done this, now I will create an else part. So now we have made the sum as, now it is only a single digit. We have taken the remainder in case there is a carry, and now we can easily push the value. We will easily calculate the value of L1. We will assign the value of sum as L1 value and then L2 value. Again we are calculating the sum. Alright, so now we have created, if the condition is this, you will do this, and if there is no carry, that means when you will divide the sum by 10, you're not getting any carry. So in that scenario, what you're just going to do is you're going to take the sum as L1 value plus L2 value. Alright, so next thing is, when you have got this, now we will have to just do this L3 next. So now I'm going to assign another node, which is the next node, and I'm going to write, again use the same thing, list node here, malloc function, size of struct list node. Alright, let me just make some space here. Alright, so now what I've done here at this point is, now you can see that if the value of the sum is, when you divide it by 10, it's not greater than 1. So now I will again calculate the value of sum, and in the next, you can see in the next node, I'm going to just assign, I will just allocate a new node, and the value of the L3. Alright, so another case here. So if the value of the sum is equal to 9 and the value of carry is equal to 1. So now you can see I have another case here. So what will happen? Let's talk about this case, which is our step 4. So let's suppose you have linked list 1 where you have values 9, 9, 2, or let me just make it 8. And here you have another linked list, which is linked list 2, which has values 3, 1 and 2. So when you will create another linked list L3, 9 plus 3 gives me 12, and you're going to calculate the remainder, you will store 2. The value of sum is 2. Then you're going to allocate a new node. So a new node is allocated. That's what we have done. That's why we have written this line. L3 next is equals to allocation. You can see here. That's why I've written this line. Because after you have calculated the value of sum, now you can see the value of sum in the next step is 9. So if the value of sum is equals to 9 and there is a carry also, and if the carry is equals to 1, so we will have to maintain this case also, that if a case will come where the value of sum is 9 and carry is 1, then in that scenario we will have to push 0 here and the value of carry will again be 1. So you will have to maintain, you will have to find out these cases on yourself, and once you will be solving a lot of problems, you will be understand these cases. So in this case, if you have the value of sum equals to 9 and there is already a carry from the previous operation, we're just going to assign the value at the next position as 0, and then we will also assign the carry as 1, because in the next step the carry will be 1. So now let's do this. Now let's implement this test case also. So if the value of sum is equals to 9 and the carry is 1, so what we're going to do is we are just going to assign the value to the next node, and remember you will have to first allocate the node. You can see that I've allocated a node L3 next. You can see I've allocated it here. So you will have to allocate it first, and then only you will be able to use the variables. Or now I will make the value of carry is equals to 1. So now we have done another case here. So now the last one in the else part, so if the sum is not equal to 9 and if the carry is not even equal to 1, and these both conditions are true, so if this is false in the else part, what I will just simply do is I will assign the value of the next node as the value of sum plus the value of carry. Alright, so in the else part we will create you can see I've created a node L3 next, and what I do is I assign the value as sum plus carry. So let's suppose we have sum. You can see that the sum is 8, or let's take this example, this one. In this one 2 plus 3 gives you 5, and if there is another carry, so let's take this example. In here we are handling carry. Alright, so 9 plus 3 will give me 12. I will store 2 and 1 here. So you can see in the next part we will have to add the value of sum and carry. So sum gives me 4 and 1 will be the carry. So that's why it's important to initialize the value of carry as 0. You will have to initialize initially at 0. And now simply what we are going to do is we have assigned the value. The next task is to make the pointer next and again next is equals to null. Alright, so the reason why we are doing this is remember that in case of linked list you will have to take care of the pointers. Whenever you're allocating a linked list, you will have to make sure that the next pointer of that particular node that you have allocated, you're assigning it as null, or it should be pointing to some other node, or else the program or the system will crash. Alright, so now we have done this, and now we have managed to do this. So you can see the value of the carry will in the next iteration it will automatically become equal to 0. So it is reset after each iteration. Alright, so now I'm going to, now you can see I have created a variable, temporary variable, which is pointing to the sum. So initially this sum was having the value, this one, L1 value plus L2 value. So the reason why I've taken this temporary variable, there is a reason behind this, and the reason is that you can see the value of sum was 12 in this case, 9 plus 3 equals to 12. Now you have changed the value of sum equals to 2. So we have actually lost the value of the actual sum, which was sum equals to this value 12. So we have lost this value, so that's why we are assigning this value as to some temporary variable so that we can actually need it later. So now here I'm going to write the last line, the last case. So if the value of temp divided by 10 is greater than equal to 1, we are going to assign temp is equals to temp into 10. So what is the meaning of this case? So let's understand the meaning of this case. So the value of temp, you can see from the previous example, was 12. When you will divide 12 by 10, you will get a value which is greater than 1. So now what I will do is I will assign temp is equals to temp into 10. So into 10 will make the value of the temporary variable. You can see the value is initially 12, so it will make temp as 120, and in this case we will just make it 120. Alright, so this is just a mistake. What I will have to do is, in case we have the value of temp is greater than 1, which means we will have to make the carry as 1. because initially the value of temp was equal to the sum, and sum is equals to 12. So when you will divide it by 10, it will be greater than 1. So we will make the value of carry as 1. And the reason why I have used this temporary variable, why I have not assigned the value of carry here only, where we are actually testing this case. You can see that these two cases are essentially the same cases. Then why I'm writing two different cases? Why I cannot just write it here? Why I cannot just write carry equals to 1 here? The reason is that initially the value of carry will be equal to 0. So if I will make the carry 1 here, then it will just calculate the sum, which is 9 plus 3 equals to 12. Then the sum will be equal to sum mod 10. Then it will be 2. So if I will make carry equals to 1 at this point, in the initial case only, it will make it 2 plus 1, 3, which will be wrong. So first we will have to add the carry, and from the next iterations onward, we will have to maintain this carry variable. We will have to change it. Alright, so in the else part, what I'm just going to do is I'm going to assign carry is equals to 0. So after we have done all the now we have done all the test cases, I will just go here. I will end the while loop, and before ending the while loop, we will have to change the values of L1, L2 and L3 to point to the next node, because after each iteration we want to go to the next node. L3 next. Alright, so now after iteration we have done everything now, and this is basically our else part. So I will just cut it from here. You can see this was the end of the while loop. Alright, so now here I will paste it. So after maintaining all the test cases, now we can actually change the values of L1, L2 and L3 pointers. So after we have done this, this is the end of the function itself. And now what I'm going to do here is, this is a really very important task. So what will happen if now we have traversed through the whole linked list? So let me just go here and explain you this. So let's suppose we have a linked list L1. Just let me go here, make it much more clear. So let the L1 will have 9, 3 and let's say 8, and the value of L2 will be equal to, let's say, 2, 1, 2. So when we will, so you can say that this is the step 5, or this is the case number 5. So when you will add these two values, the value of sum will be 9 plus 2, 11, and we are going to store the remainder here, and the carry will be equal to 1 according to our temporary variable. And now when I will add them, I will allocate a new node, and then I will add them. 3, 4, 5 gives me 5. And now if I will add 8 plus 2, it gives me sum equals to 10. So now we have reached the end. You can see that this is the end. So the while loop will end after this. So 8 plus 2 gives me 10. So the value of sum will be equal to 10. And then after this operation, the value of sum will be equal to 0, and the value of carry will be equal to 1. So you can see that after doing this, it will allocate a node and it will just assign it 0. So you can see that 8 plus 2 gives me 10. That means that there should be another node which will have the value 1, same as the carry variable. So we will have to maintain this last case. So whenever we have traversed through the whole while loop, we have traversed through the whole both of these linked lists, and we have reached the null state. That means that we have exited while loop, exit while loop. And now after exiting while loop, if the value of carry will be equal to 1, I will assign a new node in the linked list 3, and I will give it value equals to 1. So this will be the value. So let's do this last task, and I will write if the value of carry at this point, if it is 1, I will create another node using the same line. Then I will use the malloc function, and here I will use the struct list node, and here I will have to give the size of. Alright, so now we have allocated a new node. The next task is to simply assign a value to this node. So I will assign L3 value. Val is equals to 1. And then I will assign the next value equals to null. So alright, so we have done the whole program here. So now we have maintained all the cases, we have done all the allocations. So the code, this whole code, I will just give it in the Android application. You can download it from Google Play Store. I've given the link in the description below, so you can download the app. I will give the code inside that. Just go on the competitive programming course and you will be able to find it. It's absolutely free, and there is the codes are also free, so you can just go and check it out there. So now you can see I've assigned the another node when the carry is 1. So we have seen that this function actually returns the linked list. So the resultant linked list is the L3. So but we know that the pointer, the reference L3 is now pointing to the last node, which is the null node. So what I will just do here is I will we know that once we have traversed in a linked list, so let's say now I have traversed along the L3. So now L3 will have to change. First it is pointing to the first node, then second, and then finally it will go to the last node. So after it will go to the last node, there is no way to come back to the head, and that's the reason we have stored the result initially. So that's the reason we have stored the initial reference L3 to the result. You can see from here, if I will scroll up, you can see at this point we have stored the reference to the first node. So now what I will do is I will just return, and since this is pointing to a null value, I will first make it result is equals to result next. That will point to my first node, and then I'm just going to make a return call, return result, and we know that the result is basically the resultant linked list, like this. So now what you can actually do is the last task is to run this code. So here you can see run code and submit. So before submitting, you will first have to run this code. So let's run this code, and it will open up the console. It will start judging. Alright, so it says the expected identify this at line number 79. Alright, I have already created these. Let me just remove them. Alright, so let's run this again. So it gives some error here. So let's see what this error is. It says that at line number 33, the member accessed within the null pointer of type this. Alright, so where is line number 33? It's here. You can see that struct list node null. Alright, so at this point we're experiencing problem with the null pointer. So I've told you that whenever you have assigned a value, you will have to make sure that you manage the null pointers, or else it will give you the null pointer error. So the problem is with linked list in the line number 33, which is our linked list 3. So that means that in some place we have tried to access some null pointers. So I can see that here we have done a problem here. We will have to make it the next, and this should also be next, because whenever we are allocating a next node, and if the next is null, we will have to use L3 next, right? So then again here it will be next. So looks great now. So let's try to run this program and hope this time it runs well. Alright, so again it's giving us the same problem. So now the error is that if you will take this else part, you will be able to see that if the value of sum, when this value or this test case evaluates to be true, then only you will do this, right? So if the value of sum will be greater than or equal to 1, you will do this method, which is to find the remainder. In the else part, you can see when you assign the value of this, so if the value of sum divided by 10 will be less than 1, then only we are assigning this new node. But this should not be the case, because even if the value of the sum divided by 10 will be less than 1, then also we will have to allocate it. So what we'll have to do is this else part, we will have to just remove this bracket. You can see that we will have to remove this bracket, and we will have to just end the else part here. So that was the major thing, right? So that was actually causing the problem. And so now what will happen, even if the value of sum divided by 10 is less than 1, then also it will allocate it, and then it will go on checking all of them. So this is the code. Let's run this code and let's see if there are any other errors remaining in this code. Alright, so now you can see it says that it has taken some input and the output is also correct. So now we have a correct answer. So now you can just submit here, and it will do some more test cases, and basically it will accept all of them.